Good morning, Miss.
Can you see the slides?
No,
No, you can
ഇല്ലില്ല
once.
ക്ലിയർ ആവുന്നില്ല അത്. ഇപ്പൊ ഓക്കെ.
Okay. And so your attendance, Afla, Ajmina, Amaya, Atulya,
Present, Miss.
Drishya, Jyotish,
Present, Miss.
Karthik, Kavya,
Present, Miss.
Nachiket,
Present, Miss.
Neeraj, Rangeet,
Present, Miss.
Vaishna, Vaishnav, Anjali, and Shruti.
Present, Miss.
Afla is there? Ajmina?
Yes, Miss.
We will start today's class. So I hope you all have written your series exams well. And as a recap, I will just tell what we have learned in the previous classes. We were dealing with the network layer. Now, I have told you have got various functions of network layer. Out of that, what we have gone through is the addressing scheme. So, addressing is the one of the functions of the network layer. And also, what is the main responsibility of network layer is to deliver packets from your source host to destination host. Okay. And also you have learned, now I have told you what is the importance of addressing. If you want to identify a device in the network, you need an address. So in the network layer, you will call it as an IP address or a logical address. Now this IP address, you can have two versions. One is version 4 and the other one is version 6. Now version 4 is a 32-bit long address and the total number of address space is 2 power 32. Okay, now after that what we have learned is you can denote it in two ways. One is the dotted decimal notation and the other one is the binary notation. And I have told what is the importance of representing it in dotted decimal notation. Okay, and you have gone with several examples how to write the corresponding decimal equivalent. And also you have learned the concept of classes. Now IPv4, they make use of the classes. So class concept. You can have 5 different classes. One is class A, class B, class C, class D, and class E. Okay, now each class, excuse me, you will be able to find the classes if the address is given for you. You will have some range, and finding out the range, you can identify to which class each IP address belongs. Okay. Now also you have seen what is the concept of what is the importance of net ID and host ID, and the length of the net ID and the host ID varies between each classes. Okay. So remembering when I am telling the concept, you just recollect what we have learned. Okay. And also I have told you have got fixed variable, block size as well as the number of blocks in IPv4 addressing. And you have seen what are the values in that. And you have seen what is the concept of network address. What is the importance of network address? How will you able to identify how a router is able to get the network address, and also you have learned what is the concept of subnetting. If the subnetting concept is not there, you will have 2 levels of hierarchy in IP address. But if the subnetting concept is considered, you will have 3 levels of hierarchy. And also I have told what is the importance of subnetting. If you want to group your host, you need the subnetting. You will be doing the subnetting process. Okay. And in order to identify the subnetwork address, you require the mask value. 2 type of mask you have, default as well as the subnet mask. And with the help of that mask, you will be able to identify the subnetwork address. And I have also told you will have a boundary level masking and the non-boundary level masking. Okay, and also I have told what is the disadvantage of classful addressing. Classful addressing, majority of the addresses were wasted in class A and B, and the class C, the address was not sufficient to satisfy the needs of the organization. Okay, so classful addressing is almost obsolete now, and we have gone with the classless addressing. So classless addressing, what we are doing is you will have variable size of blocks. Each organization, how many addresses are required by each organization, and they will be provided by the internet service provider. And they will be giving the mask value as well as the first address value. And I have told how you will be able to identify the first address, the last address, and the total number of addresses given to an organization. Okay, depending upon the value, mask value. And also, you have learned what is SIDR notation. That is very important in classless addressing. What is that SIDR notation? And after that, we have gone with IPv6. IPv4 was 32-bit long, but IPv6 is 128-bit long. And you have learned how you can notate this IPv6 addresses. That is hexadecimal colon notation you are making use of. And you have learned how you have to make it in more abbreviated form, each hexadecimal notations. And if some range of the address is given for you with a double colon, how you will be able to identify the original address. That also you have gone through. Okay. And also I have told what is the importance of unicast address, multicast address in IPv4 as well as in V6. Okay, so these were the things that we have learned up to the previous class. I hope you remember some concepts of this thing, what I have told just now. Okay, Afla is there?
Yes, Miss.
Afla, Amaya? No. Drishya is there? Karthik?
Yes, Miss.
Yes, Miss.
Then Neeraj? Okay. Vaishnav? Vaishnav?
Yes, Miss.
Shruti? Okay. Anjali? Anjali is there? Anjali has not gone. Okay.
അഞ്ജലിക്ക് ജോയിൻ ആവാൻ പറ്റുന്നില്ല എന്ന് പറഞ്ഞായിരുന്നു.
Tell her to contact class advisor.
Okay, miss.
Okay, so we will start today's topic. Now, last class I have just given a brief introduction of the network layer protocol. I have told you to recollect the TCP/IP model, and also I have told what is the protocol used in TCP/IP model at the network layer. So that protocol is called it as the internet protocol. So you can see it in the diagram. Where is the position of IPv4 in TCP/IP protocol suite? So that is between, in the network layer, you can have other protocols also, but the major one is the internet protocol. Now, the internet at the network layer, I have told it is a packet switched network. Packet switched network, you can have two approaches in that. One is the datagram approach, and the other one is the virtual circuit approach. So switching, they make use of the datagram approach. And also you have a connectionless service, unreliable connectionless service in this network layer. Now, what is the meaning of connectionless? Connectionless means when the packets are coming, you will treat each packet independently. So you will have a message, you will be dividing it into packets, and each packet don't have any relation with the packets that is belonging to that message. The meaning is the packet can take on their own path through the, whichever path they want, they can take it and they will reach the final destination. So there is no relationship between the other packet. Sometimes it may travel in the same path, sometimes it may not travel in the same path to their destination. So IPv4, you can tell it as an unreliable connectionless protocol, datagram protocol. So whenever the data is coming from the data link layer to the network layer, the protocol, it tries its best to deliver the packet to the destination. Since it is unreliable, you don't have any guarantee that the packet reaches the corresponding destination. Okay, now here the important thing what you have to study is the datagram format. IPv4 datagram format. Last time it was asked in some question papers, discuss about the datagram format of IPv4 and v6. So you should be able to remember the datagram format. Now what is datagram? Datagram is nothing but the packets in the IPv4 layer are called as datagram. Okay, now you can see it in the diagram. You can have two parts in that. One is the header part and the other one is the data part. So you can call it as a variable length packet, which consists of two parts. One is the header part and the other one is the data part. Now, when you are considering the header, it is 20 to 60 bytes in length. Now, what does it contain? It contains the information that is essential for routing and delivery. If you want to deliver the packet, if you want to identify which route you have to take, all those details will be present in the header field. Okay, so the header field is the first field. It is 20 to 60 bytes in length, and whatever information is essential for routing and delivery, that is contained in the header part. Okay, now this header, it can have various fields. The first field is the version field. You can see it in the diagram. It is written VER. Okay, so this is a 4-bit field. 4-bit field, what it defines is, it defines the version of the IPv4 protocol. If you are considering IPv4, you will have, it is 0, 1, 0, 0. That will be the 4-bit address. If you are selecting IPv6 version, you can have 0, 1, 1, 0. So which version you are considering, that is denoted in the first field. And that is a 4-bit field. Okay. Now, the second field is called it as the header length field. Header length. This is also a 4-bit field. What it defines is, it defines the total length of the datagram header. It defines the total length of the datagram header. Now, what is the importance of that header length is, it is needed to determine where in the IP datagram the data begins. So I have told you have a header part and you have a data part, and you should be able to identify where exactly the data starts. So header length will be specified. So after that, the data will be started. So that is identified and represented in the second field. Understanding? So the first field will be the version field. Second will be the header length field. Now the third one is the services. Services, you can call it as type of service or TOS, you can call it as. Now what is the meaning is, what it does is, it allows different types of IP datagrams to be distinguished from each other. See, some IP datagrams may require low delay. Some may require high throughput. Some will be of high reliability. So whatever services they are provided, that is specified in that field. As an example, you can have two types of services here. One is the service type and the other one is the differentiated services. Okay, so what I have told is comes under the type of service field. Okay, so here how many fields you can see? 3, 4, 5, 6, 7, 8 fields you can see in service type. Okay, service type field, you can have 8 different fields. The first 3 bits, which is marked in yellow color, that is called it as the precedence bits. And the next 4 bits, what it denotes is, they will denote the type of service bits, or in short, you can call it as TOS bits. Okay, and the last bit, it is not used. Okay, so service is, the first is the service type. You can have 8-bit field. Out of that, only 7 will be used. Three, the first three is called it as the precedence bit. Now, what is this precedence? It is a 3-bit field. The value can range from 0 to 7. Now, what it indicates is it defines the priority of the datagram in issue. If there is a congestion is happening, if there is an issue, which packet I have to give the priority. So that is defined in that precedence field. Okay. The next fields are called it as the toss bits. Toss bits, I have told, they represents the IP data. Some packets will be requiring load delay, load delay. Some will be requiring throughput, maximize throughput, minimum cost, and maximum reliability. So all these things are represented in that toss field. So you can see here the toss bits. You can have, I told it is a 4-bit field. So you can have various values of that. So depending upon the values, you will be able to identify. Once if the bit pattern is set at a time, you can identify which service is required or which service is used. Okay, so if the value is 0001, the IP datagram, it requires the low cost service. Okay, so that is specified in the service type field. Okay, now the next type of service is called it as the differentiated services. So first time I have told the service type, and the second one is the differentiated services. Now what is this actually? So here you have got 8 fields again. Out of that, the last 2 fields you are not using it. But you are using 6 fields. The first 6 bits, it makes up the code point. You can see the one which is marked in yellow. That is nothing but it makes up the code points subfield. And what is its value? So you can see what is the code point value. So 6-bit field, depending upon the category, you will have some assigning authority for that. If it is 5 don't case and a 0, you can have an internet authority. The other one is local authority, and the other one is the temporary or experimental authority. Okay, so that is the based on the service field. That is the third field in the header. Okay, so 2 type of services, service type and differentiated service. Depending upon the value, the type of the IP datagram requests that particular type of service. Okay. Now, the next field finds including the header. So what is the total length of the datagram or the packet? What is the total length of the header? That the whole length will be represented in that field. Okay. Now the next field and the second row, that is identification, flags and fragmentation offset, they all are used in fragmentation function. That I'm not going in detail because IPv4, I'm in network layer, one of the function is fragmentation. So you are making use of all the things in the fragmentation segment. Identification, flags and fragmentation offset. Okay. Now, the next field is called it as the time to leave or TTL. In short, you can call it as TTL or time to leave. Now, what is that? That field actually, it is included to ensure that
Miss clear ആവുന്നില്ല.
Grams do not circulate forever in the network. See, if the datagram should not loop in.
മിസ്സേ വോയിസ് ക്ലിയർ ആവുന്നില്ല മിസ്സേ.
Now, is it okay? Okay. So the field, what I was telling is the time to leave field. So time to leave field is included. I want to ensure that the datagram is not circulating in the network forever. Okay, so it should not loop infinite. It should not loop in the network. So what is done there? It has this field is decremented each time. So you will be setting a value, and whenever the packet is processed by a router, the value gets decremented. Okay, so once it reaches the zero, the datagram will that's specified in that time leave. Okay, now field is when
ക്ലിയർ ആവുന്നില്ല.
it is that field, that protocol field is used. How long you were hearing? Actually, the network got cut. Up to where you were hearing? Kavya?
മിസ് ഒന്നും ക്ലിയർ
ടൈം
ആയില്ല.
ടു ലീവ് തൊട്ട് ക്ലിയർ
Time to
ആവുന്നില്ലേ?
leave. Okay, now is it clear? Now is it okay?
Yes.
Okay.
ഇപ്പം ക്ലിയർ.
Okay.
ഓക്കെ.
We can see the slides? Yes or no?
Yes.
Okay.
Yes.
Okay, so time to leave, what it indicates is here, like every datagram, they have a limited lifetime in its travel. So whenever it is passing through the network, you don't have, you should not, I mean, the datagram should not remain in the network for a long time. So that field, I mean, how much time it has to remain in that network, and that is denoted in the time to leave field. Okay, so once the datagram is processed by a router, what it happens here is the time to leave field that will get decremented. They will be setting a value that will go on decrementing, and once it reaches the zero, the datagram will be dropped. Okay, so that much time it is allowed to remain in the network. Okay, so that is about the time to leave field. Now the next field is the protocol field. So protocol field, actually it defines the higher level protocol. So you can see it in the diagram. Actually, some higher layers, they make use of this protocol field. So the datagram has to pass, the data in the datagram has to be passed to the upper layer, right? So to which the protocol will be taken care of that. So that is specified in that field. So you will have certain values based on that, protocol values. So if it is the value, if it is 6, the datagram will be, the data portion will be passed to TCP. If it is 70, the datagram or the data part will be passed to the UDP. So the protocol field, it defines the higher level protocol that uses the services of this IPv4. Okay, so that is regarding the protocol field. Okay, now the next field is called it as the checksum field. Now what is the importance of checksum? You have already learned. You have written exam also. What is the importance of checksum? Yes, who will be telling? Why we need checksum? Yeah, Afla.
The data unit is transmitted is divided into
Okay,
segments of
I mean mainly what is the
segments.
purpose? What is its importance? Checksum. What you are using that?
Error
It is
detection.
it is a error
Error
detection
detection.
method. Okay, so you will be making use of. So that is that field. So the field is the header checksum field, and that is mainly done for error detection. Okay. Now the next field in the IP datagram format is the source IP address and the destination IP address. So source address is nothing but it is a 32-bit field. And what it defines is, it defines the address of the source. Okay, and you should not change the source address at any cost. So once it reaches to the destination, then only that there is a change will be there in that field. So as long as it is it is not reaching, the source address will be remaining constant. Okay, now destination address. So destination address is, this is also a 32-bit field. It defines the address of the destination. Okay, so you should be able to remember what are the different fields in the header of a IPv4 datagram, or what are the various fields in a packet. The packet in the network layer, you are calling it as a datagram, and what are the various fields. Okay, now the last field is nothing but, which is highlighted in green color, that is the option field. That means if you want to extend your header field, you can do that. Okay, now the remaining part will be the data. So whatever data you want to send it, that will be incorporated in that field. Okay, so this is about IPv4 datagram format. You will have two main parts. One is the header part, the other one is the data part. So header, you can have variable fields, version, header length, type of service, the total length of the datagram. You will be able to, for the fragmentation purposes, you should be having some identification field, flag field, as well as the offset field. And the main thing is the time to leave field, the protocol field, and the checksum field. Okay, and other than that, you will have the source address as well as the destination address. Okay, so this is regarding IPv4. Now, similarly, you can have a datagram format for IPv6. So that is what that is being shown in the next slide. Now, when you are comparing IPv4 and v6, IPv6 has got some advantages. So for the fast growing internet, sometimes the IPv4 won't be suitable. It will be unsuitable. So what we will do is we will shift to IPv6. Now what are some of the advantages of this IPv6? One is it has got larger address space. As we see in the previous class, IPv4 2 power 32 address space are possible, but in IPv6, you can, hope you remember how many bits IPv6 has? IPv6 has got how many bits? 128. So what is the total number of address space there? It is 2 power 128. So you have a larger address space in IPv6. Okay, and comparing the header format of IPv4 and v6, you will have a better header format in IPv6. IPv6. Okay, and this will IPv6 will provide more security. Now, what is the format of IPv6 datagram packet? So you can see it in the next slide. IPv6 datagram header and payload. So each packet, when you are considering in each packet in IPv6, you can have two parts again. One is the base header or fixed header field, and the other one is the payload field. Okay, now when you are comparing IPv6 and v4, the most important thing I have just told is the wonder it lies in its header field. Actually, IPv6, it is 4 times larger than IPv4 regarding the total number of address space and all, or the total number of bits. Okay, but the header of IPv6 is only 2 times larger than that of IPv4. Okay, so when you are comparing these two, IPv6 has got one fixed header, and you will have some optional headers in the payload sections. Okay, now what are the various? So first field is called it as the fixed header or the base header, and that is followed by a payload. Payload is nothing but the data, and this payload, it consists of 2 fields. One is an optional header and the other one is the data packet from the upper layer. Now the base header or the fixed header, it is of 40 bytes. But the extension headers as well as the data headers, it can contain up to 65,535 bytes. Okay, so these are the main fields of IPv6 datagram header. Now, what are the subfields in this fixed header? You can see it in the next diagram, next slide. What are the subfields of this base header? So you can see how many fields you have got. The base header is of 8 fields. You have version, priority, flow label, payload length, next header, hop limit, source address, and the destination address. So you will have 8 different fields in the base header. So similar to that, IPv6, the first field is the version field. Now here, what will be the version? It is a 4-bit field, so you will denote it as 0110. Okay, so it defines the version number of IP. The second one is the priority or the traffic class. You can call it as traffic class or the priority. Similar to that of IPv4 only. So which packet you have to give the priority if there is a congestion. Okay, so which packet you have to give the priority if there is a congestion, and that will be denoted in that 4-bit field. The next field is called as flow label. Flow label means it is used to maintain the sequential flow of the packets belonging to a communication. When you are communicating, you will have a message to pass, you will be dividing it into packet, and what is the flow of that packet? And that will be specified in that flow label. Okay, now the next field is the payload length. So payload length, it is nothing but it is a 2-byte field. It defines what is the length of the IP datagram. You are not considering the base header value, you are considering only the data part. So how much is the data? What is the length of the total data? That will be represented in the payload field. So what is actually it contains? It is used to tell the router how much information a particular packet contains in its payload. So you are giving some information to the router, how much will be the data, and that is represented in the payload. Okay, the next part is called it as next header. Next header is actually, it is an 8-bit field. It defines the header. I mean, you will have a base header and you will have the other header. I mean, if there is any other headers, that will be specified in the next header field. Okay, so whatever is following the base header, that will be specified in the next header field. And the next part is the hop limit. Hop limit, same as that of the TTL field, etc. And actually, this is the same concept of time to leave concept in IPv4. And that is used actually, you should not allow a packet to loop inside in a network infinitely. So you will be setting some limit, and that is specified in that field. Okay, so as I told in IPv6, you will be setting a value, and the value goes on decreasing once a router processes it. So once it becomes 0, the datagram or the packet will be discarded. And the next one was the source address and the destination address. Similarly, source address is nothing but it is a 128-bit address, internet address. What it denotes is it denotes the original address, source address of the datagram. And destination address, it identifies the final destination of the datagram. Okay, so these are the various fields in this IPv4 and v6. Okay, so you will have, so just remember at least the block diagram and you just write the concepts because it was asked once. So its syllabus, it is not mentioned, but it is asked in the question paper. So you should be able to write what is the IP datagram format of IPv4 and v6. Okay, so remember that frame format, what is the part of the header and what is the part of the data. Okay, so this by reading textbook also, you will be able to remember how much field each, how much bit each field is. So depending upon that, you should be able to write it. Okay, so today we were discussing about the network layer protocol, that is nothing but the internet protocol that is present in the TCP/IP model's network layer. Now, as far as a network layer is considered, it obtains services from the data link layer and it provides services to the transport layer. And you will have a packet or a datagram in IPv4 as well as v6, and that packet you can, in short, you can call it as datagram. You will have specific formats for that. Okay, and that is what we have discussed in today's class. What about the format of IPv6 and what about the datagram format of IPv4? Okay, now Amaya is there. Amaya is not there. Then Vaishna, she's there. And Anjali. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. How was your exams actually? How you all have written your exams? Not only CC, all the exams. Shruti?
Yes.
It was okay for everyone?
Okay.
Okay. Okay, so next class we will be learning about a very important topic that is regarding the address mapping scheme. I have told in the first module when we were dealing with TCP/IP protocol, what is the importance of address mapping. You can have two different protocols based on that. One is the ARP protocol and the other one is the RARP protocol. So what is its function? You will be studying it in the next class. Okay, so in the series exam, the questions I was asked about CSMA, I have not checked your paper. Let me correct it and I will tell what are the mistakes or what are the corrections you have to do it. Is the time was sufficient for you to write it? Karthik? Karthik? Is the time was sufficient for you? Will you? Yes or no? No, not clear. Nachiket?
Yes, please.
Yes. You got enough time in answering that?
No, miss.
No. Why?
ഏത് തീർന്നിട്ടില്ല.
Okay, let me check it, then I will tell you. Okay, so just read the textbook today itself and make your own notes. The slides I will be forwarding it next class so that one half part of the module will be over. So read the textbook and get the concepts clear enough. So refer to the 407 textbook. I think it is belongs to 23rd chapter like that, 22nd or 23rd chapter. So just look on to that and study. Okay. I think the other staff has joined. Okay. Thank you. We will meet in the next class.
Thank you.